Essentially, what we're going to talk about is a closure method to reduce financial environmental liability. Again, exciting, but we'll support it with hopefully some information that will get an understanding how this plays into our world, but also into the mining, because there are a lot of similarities from my experience in the mining industry that I've seen. In fact, some even more severe conditions that we believe this might be an appropriate product. So I'll talk to you about the road to innovation, how we got to this product that we developed, and how we got to where we are today in the development and our market growth. A little more background on the company. We're formed by geotechnical engineers, over 100 years of experience from our people. That's our foundation. We're a technical company, provide solutions more than selling your product. But at the end of the day, we are an intellectual property company. We have 12 intellectual properties, and this being the one that's driving most of our revenue in the waste business and now into other industries. 20% owned by Shaw Industry, which is a wholly owned subsidiary of Berkshire Hathaway. And why that's important, they're in our supply chain. We don't make the product, we don't put it in. We have as few moving parts as possible so we can scale up to some of the large installations that we're doing these days. So have a strong manufacturer behind us to produce was really critical as we grew the business. So there you go. This is very common in our industry. Some of you may see similar things in tailings. I like to say this is an example of a poor performing closure, but it's almost more the common performing of a closure. You have erosion rills, vegetation. You try to slow it down with these breakers, these energy breakers, but then you get more overtopping because you can't design it for every storm event. You're not spending too much money over design it. So typically you design it for 25, maybe an 100-year storm event. Still happens, erodes, dirt on the slope will erode. That's what we're dealing with. Other common failures, as we'll look, highlighting the most common ones we've seen.
Wrong thing.
You good? Those back ones are not on for some reason.
Oh,
I just hit the advance button there.
okay, those will work. So we'll continue from there.
Okay, we good? All right, so this highlights some of the more common closures. Go back one, large clay caps that during the summertime, desiccation cracks, rains, fills with water, creates all kind of damage and down at the bottom of the hill, and veneer slope failures. Another common failure that we see in all types of applications, because you're designing with membranes that protect and keep leakage from getting into the system, you have a very poor interface and weak interface friction. All that is caused by the soil component interface. We try to improve that by making a much more stable system in our design. The early approach we tried almost 15 years ago was just a membrane, an exposed membrane. But that has its own inherent problems because now what's doing all the heavy lifting and the protection is exposed to the elements, to wind uplift, weathering, damaging type of events. So one first variation of that was put a turf on top of it. So this cross section would have a turf on top of the membrane, protecting that membrane, allowing you to do everything that a soil cover would do without all the downside of a soil cover. And there, of course, you can see the comparisons. This is creating long-term stability, as you'll see later, clean water runoff and strength of the overall system. So now, to just give you an idea of a little closer look at the overall product component of closure turf. On the bottom layer is we refer to as a structured membrane. And a lot of you are familiar with that in your industry. High density polyethylene membrane that protects liquids from getting underneath it. It's got a lot of structure, a lot of friction underneath it that makes it very stable. Then it's topped by an engineered turf. Looks somewhat like a sports turf, but it's a high strength, long UV polymer that lasts for over 150 years. Again, doing all the work the dirt does without the maintenance, clearly no mowing, no sediment protection and having to clean up the runoff and clean out your sediment ponds. And then the backfill is a sand infill, a graded infill. Essentially what we're doing is compressing what is known as the vegetative component to protect the membrane and compressing that down to a geosynthetic option. Again, it's not exposed to the membrane. It gives all the protection the dirt does without the downside. Maintenance, failures, that membrane's protected, has this system across it. The energy of the water flows through the membrane into this top side of it, keeping it from washing out the sand. There's a closer look at that you can illustrate or see this illustration that shows how the sand is left in place. What you have here is a drainage media underneath the sand. So the energy of the water, is, especially on that slope, is all underneath the system. So it doesn't wash out that sand, doesn't mobilize that sand. And then you have all these fibers holding in place. Where we have concentrated flows, where you'll see we switch to a cementatious infill. It's like cement, a concrete. That can handle a lot of high strength forces in water. I'm kind of giving an overall view so you can have appreciation how we use this. This is a 55-acre closure we did up in the northeast New York. And this has the hydro binder where you have concentrated flows, that's filled with concrete, and you have sheet flow with a closure turf product that again is backfilled with a sand infill. That all gives you a long-term life, well beyond the regulatory closure period, allows the auditors to look at it as more of a retired asset versus a soil cover, which is ongoing, basically in perpetuity when you have soil on a slope. Here's an overview from the backside. This site was in outside of Catskill, New York also. Got the Hudson River here, a lot of runoff and contamination going into the site. So they closed this site. New York State approved it, one of our early approvals for a final closure system. Create now clean water runoff, stability. And the important thing here, this is an abandoned site. They have no people there operating it. What they want to do is close it and walk away. They didn't want to leave a staff there to maintain it, have ongoing costs. Just close it, forget about it, let it operate, and then just periodically check on the system's performance for water quality runoff as required by their permit. So you see the green, it can be kind of stark in some areas, especially where mining, Nevada, some locations, green may not fit in. After several years, we're able to develop this tan type, desert tan UV material. It took a while to get the UV right, so it is also done in a tan type color to fit in the environment you might be using it. So from that early stage development, that first slope that you saw we did, we have grown over the years. And part of our challenge is we have several groups we have to convince. One, obviously the owner. If it doesn't save money, it makes sense, then it's not going to do much for them. And we have to convince the regulators, we have to convince engineers. So over time, we've been able to get all these states approved. One's not shown here is Nevada is actually going through a permitting process right now with a BLM. And it's going very well for approval there on a rock acid landfill. They're populating all the different projects we've done since we formed this company. The first installation was about 9 years ago. And now we have close to 900 acres. As of actually next month, will be about 1,100 acres installed across the country. So in a nutshell, what does it do? Anything a soil cover does, except a lot better not having that liability, that long-term liability of dressing and keeping your cover systems operating. Stops infiltration. It does actually a much better job than that, than a prescriptive type of cover. Eliminates the need for dirt, eliminates dust, and eliminates the erosion that is often one of the causes of many other problems on the site. So what does it mean? It saves money. This saves money not some of the time, not most of the time, but all the time. Typical closure savings is around $15,000 an acre. It's not hard to figure out where you avoid hauling all that dirt and all that cost of that. Now, if you have soil, ample amount of soil on site, it could be competitive, maybe even a little bit more if you got excess soil that's right there to deal with. However, on the post-closure period, in our business, that's usually monitored about 30 years. I'm not sure in the mining business how they evaluate that long-term obligation, but for us, that equates to about $27,000 per acre over a post-closure period. So obviously, at the end of the day, it's got to be economical. And one of the unusual things about this, which has allowed us to expand in other industries, it hits on a rare application that is actually supported by the regulators, supported by the community, and it's less expensive. Normally, if it's environmentally more sound, regulators behind it, community likes it, it translates into more dollars. But this has been a very effective, supported system through the community. We got our start in '07, typical closures, 30, 50 acres in the garbage business, in my background in that area. And then we started doing applications of paper sludge and other industrial customers, and then moving into coal ash. Right now, the largest site we're doing is about 350 acres, closing a coal ash facility, and we have maybe another 1,000 acres in design. Then mining industry. All of them, again, have the same value proposition that we'll be looking at, dealing with erosion, dealing with soil and slopes, getting rid of that long-term maintenance costs. So question, what would we be doing there? What's in front of us? I've been to a number of mines, learning more about the industry. Certainly seen a lot of similar problems as I mentioned earlier. Some of the projects, potential ones would be reclaiming heap leach pads, tails impoundments, or even acid rock pit. And right now we are, as mentioned, permitting through the BLM an acid rock dump that's going very well. Our biggest challenge is people expect vegetation, soil, because that's tradition. People have a hard time changing their habits and tradition. Mentally getting over what a soil cover is versus the economic and environmental advantage of a synthetic cover. Forgetting that it's a synthetic cover, what it does, it creates great clean water runoff. You don't have to maintain it. Long-term stability for over 150 years, and just creates a whole other more benchmark of predictability in the cost. And that's our challenge. And my challenge when I work for an operating company is predictability. You have a closed asset. You made all its money, it's closed, and now what do you do on the balance sheet? You know there's going to be cost, unbudgeted cost many times when you have a storm event. We used to stare at the Weather Channel all the time, knowing we're going to spend our money. I'll tell you, if there's one thing that's changed, we don't look at the Weather Channel much anymore. It just does not have that much of an impact. So you guys may think about how this relates to the mining industry. We see real opportunities there, and we're very hopeful for that in our future. So that gives you kind of a review of where we started, industries we looked at, and now what's behind the innovation. We have volumes of technical data. As you can imagine, getting approved by the US EPA in a lot of states with a synthetic turf, you got overwhelmed with technical data. So we have a whole library of information. I'll hit on some of the basic components that achieve these three things in the US EPA. Some of this ties into mining. Some of it also ties into the industrial Superfund sites, which are closing now as well. Really, it's these things: significantly less leakage. We don't have a hydraulic head. So any geotechnical engineers or hydrologists know that the hydraulic head is what creates a leak. We've shrunk that from a couple feet to that. So your chances of leaking have really reduced, because that's the most important parameter in your leakage. We model that, we've shown that, and then a less erosion. In the US, you're allowed to 5 to 10 cubic yards per acre per day of erosion, because that's what you get with soil loss and rain on the slope. This gets rid of that, eliminates that part of it. So we easily satisfy that part of the regulation. And the longevity. Typically, our permits for our customers range from 30 to 50 years of post-closure bonding. Some form of a letter of credit or some financial mechanism to make sure that you got that covered. We show over 150 years of longevity with minimal maintenance. So that has a big impact. So that's where the community, the regulators, and the owners start to come together that look at this as a viable option. So going through the testing, it really comes down to the components. The structured membrane, which is used now in mining, it's nothing new. It's HDPE, it's used everywhere. So the part that's doing the heavy lifting hasn't changed, which is good. We're not radically changing the environmental protection. We're just changing how it operates, how that post-closure system works, and how you protect it. So from that, we've joined many labs. Colorado State does a lot of testing for us. We have one tunnel test at Dobbins Air Force Base in Atlanta to show how this thing can provide this long-term weathering over time and get that performance. And then in southern Arizona, we have a weathering lab that provides our weathering data for us and this longevity. Two of the major tests that we do is a rainfall test. This is actually indoors, models a 6-inch per hour rain event. Basically shower heads on a slope, seeing how much sand loss, how stable is this system over time. And then we have an overtopping test that was developed by the federal government after Hurricane Katrina. When the waves top over the levee, what happens? Usually a levee fails because of overtopping, not crashing against it. That energy water going over the levee, undermining it, and causing a failure. So those are two important tests that you certainly couldn't pass with a soil cover. So again, we're trying to create a higher technical standard that they haven't seen overcoming as a synthetic grass. So doing this, investing a lot of work, we're able to show the type of robustness of that product over time. Let me get this video that will illustrate this pretty clearly. Yeah, I got it. So this is a hurricane overtopping test modeling Katrina. That ran for 13 hours. That used our cementatious infill to show the ability to perform. The Corps paid Colorado State $3 million to build a system to find out where products fell, whether it's riprap, articulated concrete block, some type of energy dissipators. They didn't pass that scope because this never failed. They ran it for 13 hours. They even beat it up with picks to see if there's any head undercutting, all that. The importance of that is water does concentrate, whether it's big tailings or if it's a landfill. So sheet flow is fine, we mastered that, but what does it do in concentrated areas to show that long-term performance? So moving on, in our coastal areas, we got approved by the US EPA, who manages the Virgin Islands with wind speeds of 150 miles an hour. To do that, we had to do a wind tunnel test. Just giving you a quick overview of that. We always like to show it because we spent a ton of money on it, and it's kind of therapeutic every time we use this slide to kind of feel like we're getting something out of it. So this showed it modeling at very high speed. California required it. Now it's kind of a common part of our application submittal, because at the end of the day, it's a membrane and a turf. Does it handle those winds? And what we learned from running this test is something very unique happened. We designed our system with 10 pounds per square foot of a sand infill, sometimes a little bit less based on wind load. That's a ballast over the whole tape, over the whole landfill. So you can imagine 10 pounds per square foot, even 6 pounds per square foot. That's a lot of weight. What we realized, this is tested without any infill. So now the infill is more of a redundant ballast system. What the turf does is break up the wind. That wind, when it's broken up, basically you go from a laminar flow, which creates lift and suction, kind of like an airfoil, a wing of a plane. So wind speed, it lifts. This makes it turbulent. So it loses all that ability to suck the system up and pull in the air. So what we have here is you see an increase in pressure of 0.1 pounds per square foot. Wish I could quickly do that metric for you, but you get the idea. 1.1 pounds per square foot. That doesn't exceed the weight of the product without the infill. From that simple test, that simple, very expensive test, we rapidly started getting approvals throughout the state. California approved it, final cover system everywhere, which sent a message clearly across the country. If California approves it, people start looking very, very hard at it. Another part, without getting too boring into the technical side of it, but addresses the most common failures in all geosynthetic applications on slopes, and that is veneer failure. We use spikes on the bottom of the system, creating almost like a Velcro effect. Very high strength connection and interface friction with the soil base. We run up a factor of safety of 1.4, even at 1.5 to 1, which is extremely steep. Normally more than the regulators would even allow you to go. That would fail under a traditional system with a soil cover. In fact, 3 to 1 is pending failure at a factor of safety of just over 1. So that's important because that's where it starts. The stability, the long-term performance on that friction. So with this unique spikes and the turf connection, creates long-term stability to allow that system to perform. Real quickly on the Arizona weathering, the obvious question that we get asked, how long does it last? Or does it fade? Well, the polymers we use are HDP, a lot that's used also in the membrane. The longest, most weathering resistant membranes there are polymers there are. And we add a very strong UV package. It's formulated just for us. It doesn't exist anywhere, any turf or synthetic backing. So that allows us to get this longevity out of it and taking 10-year data points, which has allowed us to grow the company. It's hard to do it one data point and say, promise you it'll do well, but over time, we get more data points, more information to prove the longevity of the product and have independent weathering consultants to show the longevity. So what this curve is showing you here, at various formulas to calculate longevity, we're at 176 years to 247 years. at 50% half-life. That's half of the original tensile strength. The thing that's interesting there, that is still 4 to 5 times more than we need to perform. So we cut it off at that period of time. In fact, we generally will just go 1 log scale, just to be real conservative. That's what the weathering industry recommends you do. Take your real data, go out 1 log scale, so report about 100 to 150 years, and that's Arizona. So the more data points we get, obviously it supports this graph that we're doing of projected longevity. So as you can see here, the original turf fiber strength, and then the proposed at 100 years, and this is the required strength here. So a lot more. So now we've just gotten through more of operation, driving on it. Equipment's very important. We do a lot of studies. You can drive very heavy equipment on it. That was critical for our approval to withstand heavy loads and weights. I don't know how important this is into your world. It's important in parts of the country. The carbon footprint, as we were told in a public hearing in California, is significantly lower with our system. This is data that was presented to us. We turned it into a technical paper and presented at a conference. So 80% reduction in carbon footprint during the construction of the system. It's a significant drop, mainly because you're not moving and hauling all that dirt. That's the main component in that system that reduces it. Very well accepted in California, almost for that reason alone. Water quality, it's the biggest issue. It's the biggest pain from the industries I've worked in. What I've learned, if you want to have success in industry, take away their biggest pain. So we have accomplished the system basically creates filtered water, and we'll go over some of these projects that shows and illustrates that. One of our power companies, they have a demand to draw less water out of the river. We're generating 100 million gallons of clean water from runoff of their closure of their coal pits. So they stabilize their system, no more maintenance because they generate gas, and when they generate electricity, they're not in business operating landfills, but yet it's producing clean water for them. It's been a very attractive thing for the business. So what's important is really just trying to go through case studies as we're getting close on time. The next best thing to seeing the system is good images, but you really have to look at a site to get a full appreciation for it. This is a 140-acre sludge lagoon, ash, paper sludge. Maybe you can think of some applications in the mining world, but this system was so weak, referred to as a CBR of less than 1, which mainly means if you stood there, you would start to sink. So how do you cover that? With a soil cover, you couldn't do it. You'd have to de-water for years, treat that water. What our customer here decided to do is to cover the system and de-water as they covered. They saved millions and millions of gallons of treatment by go ahead and covering it first, kind of like a triage. Cover it, keep the infiltration out, save on the water treatment, and then over time, of course, you're taking water out, you're going to get settlement. I don't know if you can see in the corner here, but that's about a 15-foot settlement. That's expected. But they've saved so much on water, and they got rid of, in this case, also a lot of odors and a lot of nasty runoff. So we are now in the second phase and filling in those dips and valleys, creating the positive drainage. It's a huge win for them financially, enough that it actually paid for the cover system itself. Fortunately for our technology, we've experienced many floods, hurricanes. This is in South Carolina. Maybe you've heard some of these stories where massive erosion and failure, where they had appropriate cost to repair it, except on the closure turf. You can see the non-closed side here, badly eroded. They actually had cleaned out some of the ditches. Here, there was no work to do. A tremendous amount of rain over 3 days. Flooded a good portion of South Carolina, if you're familiar with that story from a few years back. Florida, this is something the Weather Channel we looked at later referred to as a water bomb. They've never seen anything like this. 22 to 26 inches of rain over a day. Not anywhere can that be found. We're right in the middle of that. So the site was bombarded. Again, minimal maintenance. You'll get some sand washout of fines, and people are familiar with sieve analysis. That's the 200 sieve and finer material. Yeah, it washes out. So about 3 days of maintenance, it got it back up to speed. One important thing about this system is you can construct it during bad weather conditions. If it's raining, you stop. With a soil cover, my background is geotechnical engineer, you got to stop, you got to let the soil dry, you got to process, you get back to work, then it rains again, you keep going backwards. You make very little progress. This, if it rains, you stop, stops raining, you can get back to work. So for this 25-acre closure right here, we finished in just under 6 weeks. So very speed, very, very fast, and some of our customers, obviously for that reason, is beneficial to them. Water quality, this particular site was getting fined $50,000 a month for not meeting their turbidity. That's sediment they could not take care of into their ponds. And that's again where that sample came from. This won an award in the Australasia Conference of Geosynthetics, how they treated that site for water quality. All these are examples, extreme example case studies for us that have developed this product forward. California, community around it. The 76-acre closure, they had to destroy 15 acres under their old plan of borrow soil to bring it in. So they presented this to the community as saving 15 acres of land that once it's excavated, it's gone forever, by using our system. So they have to take that dirt, haul it in, which would equate to almost 60,000 truck trips through that community. It's also in a highly seismic area, which many mines are. This is right off the San Andreas Fault, and it withstood seismic activity, and this is about a 2-to-1 slope on that edge. Without closure turf, they would have had to lay that slope back, make it stable under those conditions. Northwest, that's looking towards Victoria, kind of Mount Olympia, behind you, showing severe slopes. You get an idea here how severe that slope is. So ability to handle a lot of extreme situations. And as you're early on in our business, the business comes from those people that either have big issues or they're just early adopters. So now we've kind of flushed through the early adopters. We have enough extreme conditions that we're seeing that traction of more sites and more state approvals, which obviously is a critical part of it. Solar, as we finish up here, kind of post-closure use, may have value, may not, but certainly a lot of our customers, especially the utilities that have a knee in the back, they got to produce so much green energy, are developing solar arrays. So we integrate a ballasted system that doesn't create any penetrations to the turf, operates, you can put it on a year or two afterwards. Doesn't require you to penetrate into the system because we have these weighted ballasts designed for wind load. This is an early version. We just filed patents on another system that's simpler, cheaper, that brings it down to almost $1 a watt. In the solar world, that's a tremendous drop in value. And that's happened across the industry in general. But we're able to minimize the racking costs through closure turf to make it a lot more economical on the solar side. So there's 1 megawatt. They're continuing on developing that way. And they're adding some side slope technology. And that's from actually Arizona State University on a 2-to-1 slope. It's been there for about 5 years to evaluate what they call a creep study. Are these weighted panels going to pull in that membrane over time? Again, that Velcro, that high strength textile and membrane is keeping that stable in place, but no one would bank side slope technology without some history. So now we're hopeful that will be a bankable solution with that long-term test on creep analysis. So that's kind of getting into some of the opportunities that we're seeing down the road that may bring this product even faster to the market. One of our bigger customers, BASF, has Superfund sites. They questioned all our customers. We sent out similar questionnaires, not going down exactly on everything in the list, but you can see what popped up most frequently was this regulatory compliance, which drove our first customers. They're getting hammered by the government. They had to do something to get them compliance, either stability or through water quality. Then, the accelerated project schedule, safety, sustainability, as I mentioned, and then for us, especially on the landfill side, water quality is a big issue. So that's kind of a list of all the different values that are provided by the product that our customers have been attracted to that's brought us to where we are in the market today. Cross-section of our customers, it's not where we expect to start, but as we've developed the technology, certainly more customers have come to us and we expanded beyond just the garbage business.